Okay, guys, happy new year to everyone. So, I need to make some chemistry reaction with you in this new year. So, because we are targeting at A stars, so hope you get A stars due for these examination sessions. So, I want to revise some chemistry with you guys. So in this lesson, we'll go one by one. First, I'm going to define what is atomic number. So what do you mean by atomic number? Atomic number is simple. Atomic number is the number of protons in an atom. So atomic number is the number of protons. Next, we'll talk about the mass number. So what do you mean by mass number? Mass number is the number of neutrons plus the protons in an atom. So simple as that is the number of neutrons and protons in an atom. Next, we'll talk about relative atomic mass. Relative atomic mass is the mass of an atom compared to 1/12 the mass of an carbon 612 isotope. So that's about relative atomic mass. Then we'll talk about first ionization energy. What do you mean by first ionization energy? Simple. Suppose there's an gaseous atom E in gas state, so we need to write. So when first ionization occurs, it undergoes a reaction like this. So it forms a gaseous E singly positive charge ion. It's also in the gas state and remove an electron. So this for this reaction to occur, it does an enthalpy change. So this enthalpy change or the energy change is known as the first ionization energy. So it is simple as that. So next we'll talk about the second ionization energy. So what do you mean by second ionization energy? It's the energy change for removal of one electron from a singly positive charge ion. So singly positive charge ion will take at E plus. It's in gas state. It goes to E, say the charge 2 plus, because one electron is going to be removed. So and it removes an electron like this. Then enthalpy change for this reaction to occur is known as the second ionization energy. Next, if we talk about ionization energy, we need to talk about electron affinity. So what do you mean by electron affinity? Electron affinity is the energy change when one electron is gained by a gaseous atom to form a singly negative charge ion. So first electron affinity is defined as forming a singly negative charge ion. So let's take an example for this thing. So if we take the atom as X and it's in gas state, it's going to gain an electron. So we need to add an electron for this. Its electron is negative. So form finally an E minus ion. And you must remember the first electron affinity is always exothermic because we bring a negative charge electrons to as a positive nucleus. So remember that the first electron affinity is always exothermic or negative. So because we are bringing a negative charge electron towards a positively charged nucleus. So the next one, second electron affinity, we need to talk about this thing because it does not work the way we think, because this time we are going to bring and negatively charged electrons towards a negatively charged ion. So it's always endothermic because the electron and there's a repulsion between the electron and the negatively charged ion. So let's write an equation for this. It's simple. Let's take X minus as the gaseous atom, which is going to gain an electron for the second ionization energy. So second ionization energy, so it's going to gain a negatively charged electron. There's a repulsion between these two, so the delta the energy change is less, and we should supply energy. That means it's positive. The enthalpy change is positive, so that means it's endothermic reaction. So it forms X minus 2 minus ion. So and it's also in the gas state. So this is about second ionization energy. And so hope you understood what's second and first ionization energy. So what's the variation of enthalpy, how it's exothermic or endothermic. Next we will talk about mass spectra. So mass spectra, so it's important to identify compounds, and different things can be determined, such as drug testing or various blah blah blah. There are so much of things under this, so we need to I'm going to highlight what's the important facts. So mass spectra is only given for positively charged ions, so it's only for positive charged ions, remember. uh, and metals and noble gas form singly positive charge ions, and non-metals can also give rise to what you call as molecular ions. So if it's Br 30 what be Br 81, sorry, not 81, there can be 81 plus, and there's also another isotope, for example, I think Br 79, uh, 79. So these type of things can happen. So different MOE values can be obtained because the molecular structures can also form molecular ions. So you need to remember that noble gases and metals form single positive charge, while while the non-metals can form molecular ions. So they also can give rise to peaks in the mass spectra, and relative atomic mass of an element is calculated from the mass spectra data as follows, as sum of each isotope into percentage of that isotope divided by 100. So it's the mass of an each isotope divided into percentage of the isotope divided by 100. We calculate the relative atomic mass. Next, we'll talk about first ionization energy of elements. So the graph varies, like first it starts of hydrogen, then it goes to helium. Here we have helium, and next there will be a fall like this, and it starts with the lithium, which is in the next period, and we have then it goes on like pattern, and you need to remember this pattern how it goes. It's like this, and here it's in neon, and let me highlight the atoms for you. Here we have one atom, it goes along the period, so you can always check this out using the periodic table, and it goes on like this. And next there will be a drop because it's going to start off with a new period of sodium. So starting off with sodium, it follows the same pattern like this, but it's lower than the flat value. So and finally yeah, so we have one atom here, one atom here, one atom here, one atom here, one and one and one. And next there's a small difference in comes to the next period. It doesn't go in this same increase in power, but follows the same pattern. So it's simple as that. You can always demonstrate this, and it goes on like this along the period, and passing through a range of what you call transition metals. Then at zinc there's a sharp peak like this, and it goes on like this, and it goes down and like this, and finally ends with krypton. So this is about the first ionization energy patterns. Generally there's an increase going from left to right across a period. This caused mainly by the increase in nuclear charge without the increase in the number of inner shielding electron shells. This is the reason for that, because as you go along the period, what happens is the nuclear charge increases, but the number of shells is constant. So it tends that the electrons are of the outer shell are more attracted because nucleus is going to have higher charge when moving across period. So there's no increase in the inner shielding by electrons because no shells are added. So this is the reason for the first ionization energy across periods to look like this. Then then we will talk about we have finished talking about electron affinity. As I said, electron affinity, the values are always negative for first electron affinity because the negative electron is brought to a positively charged nucleus. And next the second electron affinity is always positive, which means it's endothermic because we are bringing a negative charge electrons to the negative charge ion. So these are the things we study under atomic structure. Next, move on. The things to learn next will be the Avogadro constant. Avogadro constant is defined as the number of carbon atoms in exactly 12 grams of carbon 12 isotope. So what's Avogadro constant? It's this basic question that you are going to ask from me. Yeah, it's simple. It's 6.02 into 10 to the 23. Sorry that I missed the multiplication sign. Then next, it's clearly defined the number of particles per mole. So this number of particles per mole. So this is about the Avogadro constant. The molar mass of a substance in mass of 1 mole. So molar mass of a substance in mass in grams of 1 mole. So amount of substance is the number of moles of that substance. Empirical formula is defined as the simplest whole number ratio of the elements in a compound. So remember that the empirical formula is the simplest whole number ratio of elements in a compound. So let's move on. So let's talk about ionic equations. I don't want to talk about other equations because they're simple. So there are three rules in ionic equations. So you are going to ask me what are these three rules. Of course I'm going to say you. The first rule is write the ions separately for solutions of ionic compounds such as salts, strong acids and bases. So write the ions separately for solutions. Next, write the full molecular formula for solids and all covalent compounds. So first you write the ions separately for ionic solutions of compounds, ionic compounds, that means ionic compounds which form solution obviously. Next is writing full molecular formula for solids and all covalent substances. Next is what we call the spectrate ions. So spectrate ions should be cancelled out from the equation so they do not appear in the final equation. So remember these things, the three rules in writing ionic equations. So next, I'm going to talk about calculating the amount of substance. So amount of substance is definitely moles. So I'm going to discuss how to calculate moles. There are three occurrences which can occur when calculating. So suppose you need to calculate the moles when the mass is given. So it's mass or RFM or relative atomic mass, RM or RFM. So this gives us the at moles. So this is the amount of substance. This one method to calculate it. Next we will talk about calculating the number of moles in a gas. Suppose you are given the volume of the gas, so you need to divide by the molar mass. So you need to divide by the molar volume. So sorry, it's molar volume. Molar volume. So what do you mean by molar volume? So molar volume is the volume that any gas occupies at room temperature and pressure per 1 mole. So it's defined as 24 dm3 per mole. So this is about this. This is how to calculate the moles for a gas. Next we will talk about how to calculate the amount of solute. That means now the moles in a solution. So it's simple. It's you need to multiply the concentration by the volume of the necessary component. So this is how we calculate the moles in a solution. That means the number of moles in the solid dissolved in the solution. And simple as that. You know how to calculate the moles by next we'll talk about how to calculate the number of particles. So number of particles can be calculated from the number of moles. So to calculate number of particles you need to know the number of moles. So it's simple as that. So what do you mean by number of particles? Suppose there's an equation, so you need to know the number of carbon atoms. So whatever ions in an equation, so it's number of how to calculate this is really simple. You need to multiply moles by the Avogadro constant, which 6.02 into 10 to the 23. So if you multiply the moles by the Avogadro constant, you get the number of particles. And the next we will talk about how to calculate the number of ions. So always there can be, if we suppose there's an equation like FeCl2, so first you need to find the number of moles of chlorine. So then first you calculate the moles, then what you do is multiply by the Avogadro constant 6.02 to 10 to the 23, and next you multiply by the number of ions in the formula. So now what do you mean by number of ions in the formula? Number of ions in the formula is 2, because 2 there are 2 Cl minus ions, so you need to multiply this by 2. So this is how to calculate the number of particles from an ionic equation or ionic formula, sorry. And next we will talk about the concentration. So concentration is defined as moles per mole per volume, and so you can also write it as concentration equal mole over volume. This one method, this is the first one you need to know. The next concentration can be also expressed as the mass of a solute divide by the volume of, so you can write concentration also as mass over volume. So different, these two are mainly and there's something called ppm, which can be, it's also a measure of concentration of very small quantities, can be expressed as mass over the total mass, that means mass of the component which is very small, a mass of total mass uh, into 10 to the 6. So this is how we calculate the concentration in ppm. You can also substitute volumes, go either way. So this is example of calculating concentration of solutions. So we discuss of next, always stay, it is an important that you state your answers correct to 3SF where it's not mentioned. So always work your answers more to one significant uh, more than it's expected, and finally give uh, your answer correct to 3SF. So leave your answers for like 4 significant figures, and leave your final answer for 3 significant figures where it's not mentioned. So these small things are really important. Significant figures, you don't want to lose marks, and it's always to be on the safe side. So next we will talk about structure and bonding. So structure and bonding, so there are different structures and bonding, so we are going to learn about these things. It's really simple, don't worry about chemistry, it's really simple. Unit 1, there's no game. So first we'll talk about ionic. So ionic, what do you mean by ionic? Ionic bonds occurs between separate ions. Next we will talk about covalent. So what are covalent? Covalent bonds can be divided into two groups as polar covalent and pure covalent. So what is polar covalent? Polar covalent is where the bonding pair of electrons is near to one atom. This is because of the difference in electronegativity. So the one atom tries to attract the pair of electrons more towards it and than the other, so it causes polar covalent bonds. And next we will talk about pure covalent. So what do you mean by pure covalent? It's simple as that. It's a normal covalent bond you're every day talking about. So pure covalent refers to that bonding pair of electrons is equally shared. So if a bonding pair of electrons are equally shared, it's known as pure covalence. So this is about the two types of covalent bonds, and next we'll talk about metallic bonds. Bonding caused by delocalized electrons attracted towards positive atoms. So you know, in a metallic structure you have positive ions arranged all over in a regular pattern, and next you have electrons like this. So the attraction between these electrons and these positive ions, the electrostatic attraction, causes the metallic bond. So this is the metallic bond. This is what happens inside a metal. So it's simple as that. So let's go to electronegativity. So electronegativity of an element is a measure of attraction uh, uh, its atom for a pair of electrons in a covalent bond. So it's how the extent that you attract a pair of electrons in a covalent bond. So this is about electronegativity. So they also say that let's talk about, before come to that, let's talk about the forces. Hydrogen bond is an intermolecular force that exists between delta positive hydrogen atom. So let me draw delta positive hydrogen atom in one molecule and the delta negative atom such as fluorine, oxygen, or nitrogen. So it's this is what defines hydrogen bonds, is the attraction between delta positive hydrogen atom of one molecule and one of these atoms like fluorine, oxygen, or nitrogen. So for a hydrogen bonds to occur, this the essential factor. Next talk about van der Waals forces. So what are van der Waals forces? Forces are between covalent molecules and caused by dipole or induced dipole, also known as dispersion forces. These type of forces occurs between covalent molecules, and those are usually weaker than hydrogen bonds. So let's talk about ionic bonds next. Ionic ionic bonds is likely if there's larger difference in electronegativities. So cations with smaller radius and have a high charge or high have a larger charge density are very polarizing, and anions with a large radius with high charge are polarizable. If either the cation is very polarizing or the either the anion is very polarizable, the outer electrons um, in the anion will be pulled towards the cation, and the bond will have some covalent character, and it bonds give rise to ionic lattices, which are regular three-dimensional arrangement of the ions. Ionic bonds is on average is the same strength as a covalent bond. So you need to know these things. Covalent bond, covalent substances. Okay, so when talking about covalent structures, it's really important that you should know that covalent structures are either giant atomic, such as diamond. They can be giant atomic, such as diamond, graphite, or quartz. SiO2 is also a uh, giant atomic structure. Then next is a simple molecular structures. So what do you mean by simple molecular structures? Like I2 and many organic compounds can be described as simple molecular structures. Hydrogen bonded molecules such as ison, methanol, and non-crystalline substances like polymers like polyethylene also contain covalent bonding. So polar covalent bonds may result in polar molecules, but the linear molecules or polar molecules, because although their bonds are polar, the polarities cancel out because of their symmetrical molecular arrangement. And when the atoms or ionic lattice is heated up, it tends to vibrate more and break the bonds. So you also need to know that the redox reactions, which involves a transfer of electrons or redox. Always remember that oil oil rig is that oxidation is losing, reduction is gaining of electrons. Oxidation occurs when a substance loses one or more electrons, and there's an increase in the oxidation of the element. So an oxidizing agent. Let's talk about oxidizing agent. So what do you mean by oxidizing agent? So oxidizing agent is it's a substance that oxidizes another substance, and while gets itself being reduced. So, and the reduction occurs when substance gain one or more electrons. There's a decrease in oxidation number when the reduction takes place. And next we'll talk about reducing agent is a substance that reduces another substance, and so itself oxidize. We'll highlight what's deproportionation. So deproportionation is that an element simultaneously undergoes oxidation and reduction. So if disproportionation to occur in a reaction, you should always note that the element should appear in the both sides of the equation, because there's no chance if there's no such if the element does not exist in both the sides of the equation. Physical properties of some gases and some halogens. Let's talk about chlorine is a greenish gas, bromine is a red brown liquid, iodine is a dark gray lustrous solid which gives a purple vapor on heating. So, and a solution of iodine in an aqueous potassium iodide is red or brown. In non-oxygen containing organic solvents, violent. So in an organic solvent it's violent, and iodine is gray solid, and also it's also violet in organic solvents. So these are, and let's talk about few tests for elements first. Chlorine, if to identify chlorine, it rapidly bleaches the damn litmus papers. Bromine is a red brown and will bleach litmus very slowly till displace iodine from a reaction, iodine from a solution of potassium iodide. Iodine turns the solution of starch blue black. So it's one method to identify iodine, and also forms a violet solution when dissolved in suitable organic solvents, such as hexane. You know these things. These are how to test for halides. So you for halides you add HNO3 plus AgNO3, and for chloride you get a white precipitate, bromide pale yellow precipitate, and for iodide you get a yellow precipitate. So these are